In this video, we'll cover up the last method of separation of components of mixtures, and that is the crystallization method. Now, to understand crystallization, I'm taking the example of getting the pure copper sulfate from impure copper sulfate sample. So impure copper sulfate we have, which has so many impurities in it which are soluble and insoluble in a solvent, and we have to remove those impurities to get pure copper sulfate. So how we do the crystallization? There are different steps that we have to follow. The first step is the dissolution. Dissolution means we have to dissolve this impure copper sulfate now. For dissolution, we are taking a beaker. In this beaker, we take approximately, we say 10 gram of impure copper sulfate in this. So after taking this approximately 10 gram of the impure copper sulfate, in this we will add water. Add that much amount of water in which this salt, this one will dissolve. So minimum amount of water we have to add. Now, some of impurities in impure copper sulfate, they are soluble in water, and some they are insoluble. So insoluble impurities, they will remain suspended in this. So these insoluble, these I'm drawing with this red color, these are insoluble impurities. So first we remove the insoluble impurities, and then we'll come to how we can remove the soluble impurities from this solution. So after dissolution, next step we have is the second step, filtration. Now this solution we have to filter to remove all these insoluble suspended impurities. For filtration, we will take a filter paper, and then we have to fold the filter paper, and that filter paper we have to put in a funnel. This is funnel. In this we have to put a filter paper. So how we have to fold a filter paper? For that, just see this paper I'm taking. Suppose this is a filter paper. So first one fold you have to do like this. Then second fold like this. So after folding it twice like this, now we'll open it like this. So when you open it, what we get is a cone we'll get. So this we are putting in a funnel like this. And through this filter paper only we will pour this solution. This solution that we have here, this will pour through this filter paper. So this is the folding of the filter paper. You have to make two folds, and after making the two folds, open it, it will be like a cone. So this is the opening of this filter paper. So after folding filter paper, put that filter paper here. That cone we have putting here. So this is a filter paper. And this is a funnel. This funnel we will set on a stand. Just put it on a stand only. And under this stand we are keeping an empty beaker. So this is a beaker here, stand, and this is a beaker. And how we'll do the filtration? Filtration, for that we are using a glass rod. This is a glass rod we are using. And through the glass rod, this solution we have to pour here. Solution will start falling on this glass rod, and through this is coming here in this funnel. So now this is like, for example, we have this glass rod and this is a filter paper. So we keep the glass rod like this here, and through this we are pouring the solution. What is the use of this glass rod here? Why we have to pour the solution through the glass rod? Why not directly into the filter paper? Because sometimes solution can be hot also, it can be cold also. So when this hot or cold solution will fall into the filter paper, it's a very thin paper, so it can tear. So when it will pass through the glass rod, then what will happen? The temperature of the solution will come to the normal. this rod will absorb the extra heat, or if the solution is cold, then this can give its heat to the solution, so it will be at the normal temperature only. And slowly through glass rod, when the solution will go into the filter paper, then there will not be any tearing of the filter paper. So just a precaution only that we have to use, we are using a glass rod for this purpose. So after pouring the solution, and what we have here is impure solution in this. And what we will see now in the filter paper, in this, these insolubles, these suspended impurities, they will remain in the filter paper, and what will pass through this filter paper is a clear solution of copper sulfate. So this copper sulfate solution will come here, and this solution is called filtrate. This solution is called filtrate, and the insoluble impurities which are left here in the filter paper, we call these a residue. Insoluble impurities, this is called a residue. So this is a second step after dissolving impure copper sulfate solution. Then we have to filter this solution, and with filtration, these impurities which are insoluble in this water, these we can remove. Now next step after this is this filtrate which we have got here, the beaker, that we need. And this step is your crystallization. The filtrate that we have collected here, this we have to transfer in a china dish. In crystallization, the first step is transfer the filtrate in a china dish. So now this is a china dish. Now this is filtrate. Filtrate has some impurities in it which are soluble in it. Now how we remove these soluble impurities from this? After transferring the solution, the filtrate in a china dish, we have to heat this china dish so that some of the water can evaporate. But see how we'll heat it. For this, we are keeping the china dish on a beaker that is full of water. So there is a beaker that has water in it. On the top of this, we are keeping this filtrate. And this we have to heat by keeping it over a stand. And now we have to heat it. So we are using a burner for heating purpose. Burner. This is called tripod stand. For heating, we always keep a wire net here, wire gauze. This is boiling water. This is beaker, china dish. The solution here is copper sulfate solution that has impurities, soluble impurities in it. And then when we heat this thing, what will happen? A steam will form here. And the heat from the steam will be transferred to this china dish. And with that heat, what will happen? The water from this will start coming out. The water will come out from this. So now question here is, why we are not keeping the china dish directly on a flame? Why? First of all, we are heating water here, and the heat of water we are transferring to this solution. What can happen? This is called indirect heating. This method of heating is called indirect heating. Direct heat we are not giving, we are giving indirect heat. The reason for this thing is copper sulfate can decompose on heating. Direct heating if we'll have, then this copper sulfate can decompose. So those substances which can decompose on direct heating, for these substances we have indirect heating. So this is a method of indirect heating, how we can do that indirect heating. On heating this thing now, the water from this thing is evaporating. Some of the water, and the solution will become concentrated. Concentrated means there will be some liquid, but now less liquid is there. So this solution now that we have got, we call this solution a saturated solution. But how we'll come to know that how much heating we have to do. Then when we will get the saturated solution, the heating has to be till a point that is called crystallization point. Crystallization point is when we are heating this, we will dip the glass rod time to time. We are dipping this glass rod in the solution. We bring out this glass rod and we have to blow it. When we blow it, after some time, we'll see some solid particles sticking on the glass rod. When those particles will see sticking on the glass rod, that is the crystallization point. So we have to heat the solution only till that point when we will see those tiny solid particles, crystals on a glass rod. That is called crystallization point. So till that we are heating it. Now next step after this thing is, first step is that we have transferred the solution into the china dish. Second is we are heating this solution and we are making a saturated solution. Now next step is we have to cool this solution for few hours. For cooling the solution, we can keep the solution in a cold water also. Like we take a cold water, normal water we can have, in that we can dip this thing. Keep it for few hours in this container. And we have to cool it. After cooling, what we will see now. In this china dish, after 5 to 6 hours minimum, in the china dish, we see some big blue color crystals here in this. In a liquid, there's a liquid. In that, we will see these big crystals of blue color. These are the copper sulfate crystals. That means it is pure copper sulfate. And all the soluble impurities that we wanted to remove, these all will remain in this liquid here. And this liquid which is here is called mother liquor. This liquid is called mother liquor. And these copper sulfate crystals we remove from this thing by decantation. Just remove the water like this by tilting this china dish and we can collect these crystals of pure copper sulfate. Next step after obtaining these crystals is we'll take a filter paper. On the filter paper, we'll keep these crystals of copper sulfate and just fold it with another paper and just dry these copper sulfate crystals by folding in the filter paper. Filter paper will absorb whole of the water from it. So these are the copper sulfate crystals that we will get. And this is the filter paper. So this is a crystallization process. I'm repeating this method. See what we have to do in the crystallization processes. Example for this we are taking is we want to get crystals of pure copper sulfate, and for that we are taking impure copper sulfate solution. So we take impure copper sulfate approximately 10 gram and dissolve that in a minimum amount of water. So what we take, very less amount of water we take in which this copper sulfate can dissolve. After dissolving it, next step is do the filtration. For filtration, we take this funnel. In the funnel, we put this filter paper. We are keeping this funnel on a stand, and under this funnel, we are keeping this empty beaker. And this solution, now we pour the solution into this funnel through a glass rod. When the solution will go into this thing, all insoluble impurities will remain in the filter paper, and these impurities are called a residue. And the solution that is passing through the funnel, through the filter paper and collected here in a beaker, this is called filtrate. This is again a copper sulfate solution, but still it has some soluble impurities. Now how we remove those soluble impurities? Next step is do crystallization. So this filtrate is transferred into a china dish, and then the solution is heated, and this method of heating is indirect heating. So first of all we heat the water, and the heat of water, that is steam heat, is transferred to this china dish. With this, the water from here will start evaporating. Some of the water will evaporate and this solution will become concentrated, or we can say saturated. And heating we have to do of this solution till a point that is called crystallization point, when we can see the tiny solid particles coming out from a solution. And this saturated solution, we have to now cool it by keeping it on a table, this china dish, or we can take a container in which there is a water at normal temperature. In that container, we can put this china dish. So for 5 to 6 hours, we have to cool this solution, and after that, what we'll see in this china dish, the crystals of copper sulfate we'll see. And this liquid which is left here, that will have all soluble impurities, and this liquid is called mother liquor. Just remove the liquid, throw that liquid and collect the copper sulfate crystals on a filter paper, and just dry the copper sulfate crystals by folding these in a paper of filter paper, folding these in a filter paper, and we'll get the pure copper sulfate. So this is the method that is called crystallization, which is used to remove the impurities from the salt.